Hello, everyone. Welcome to another LIC exam. Today's class will be dedicated to a review for the first exam. Your exam is going to be on Tuesday, upcoming Tuesday at the same time as the class. For the online students, I've posted an announcement. Their exam is postponed to next weekend. Before I start, do you have any questions about your previous class? No. So today's class, I will give you some examples which are going to be very, very similar to what you're going to see on your exam. Just maybe the numbers would change or a few elements would be, altered, but it's going to be very similar to this. And I'll give you a few minutes to think on them, solve them. If anyone can solve them, the first one person to solve any of these questions gets an extra point on their assignments. So for the first example, we have an operational amplifier connected to a current source. And we want to measure the output voltage. What is V out? The input current is 2 milliamps. The feedback resistor is 25K. And it's an ideal op-amp. Negative, actually 50. It's an inverting amplifier. I'll give you a few minutes for other students to solve. Yeah. Okay. So for an ideal op amp, the input current to the op amp is equal to 0. So what happens is all this current is gonna go through. And to measure V out, and by the way, V positive is also equal to V negative. Therefore, the voltage at this point is going to be equal to 0. So VA is equal to 0. Why? Because V positive is connected to the ground. Okay. So V out minus VA over R is equal to the current, which is 2 milliamps. So V out, sorry, I did a small mistake. This is in the opposite direction. So it's going to be VA minus V out over R is going to be equal to 2 milliamps. So V out would be equal to R, which is 25K, or negative V out would be 25K times 2 milliamps. Therefore, V out would be equal to negative 50 volts. And for all the current is going to be pretty easy question. So next question, remind me to give you bonus points. Okay, so for the next question, did you write this down? Can I go to the next slide? Okay. So for the next question, again, we have an ideal op amp. For the inverting input, it's connected to a 5 volt, a 2.4 kilo ohm, and a 12 kilo ohm resistor. And the non-inverting input is connected to a 3 volt input. Again, we want to find what the output voltage is. Yes, I think it's Do you want me to solve it or you need more time?
Makes sense.
No.
This one was at -50 or 50?
-50. Because it's an inverting amplifier, the output would be. Okay. You want me to solve it? So first of all, because again, this is a ideal amplifier, V positive is equal to V negative. V positive is here is 3 volts, therefore V negative at this point, I'm gonna call it VA, is gonna be also 3 volts. So this is gonna be equal to 3 volts. So there are 5 different ways to solve it. I'm gonna give you one of the easiest ways. We can measure this current, I'm gonna call it I. I would be equal to 5 minus 3, which is voltage here. I'm gonna call it VB, VB minus VA over its resistance, which is 2.4K. This gives us a current of 2 over 2.4, which is 0.833 milliamps. So now what I can do is I can easily replace this with a current source, which is 0.83 milliamps. Going into the op amp, and I have this 12K resistor. This is going here. Again, because this is an ideal op amp, the current going inside the op amp is equal to 0. So all that 0.833 milliamps will go inside the 12 volts. The same thing exact same thing that we had in the previous. We can use that, or we can just use a Ohm's law. It's going to be 12 times 0.833 gives us 10 volts. Since this is an inverting amplifier, the current is actually going the opposite direction. So this is going to be negative 10 volts. So technically it's 12 times negative 0.833, which is negative 10 volts. This is one way to solve it. Another way to solve it, you can use the summing amplifier equation. That's another way to solve it. Another way to solve it is to use node analysis. So again, 3-4 ways to solve it, but this is the easiest way to solve the problem. So the output voltage is negative 10 volts. When you see something like this, one other thing that you can do, you can just simply subtract the 2 inputs, because in an amplifier, it technically subtracts the inputs from the inverting and non-inverting. So I can subtract 3 from 5, it's going to give you 2, then use a inverting amplifier equation. So this would be 2, and the other one would be 0, times negative R2 over R1, which is 12 over 2.5, which gives you 5. So 2 times negative 5 gives you negative 10. So this is another way to solve it as well. So did you write that down? Can I go to the next question? Okay. So for the next question, we have an ideal op amp again. This time we have a current source in parallel with a 4 ohm resistor, and the feedback resistor is 28 ohms. And we want to find the output voltage, V out. Do you need more time, or do you want me to solve? So you already got the answer. What is the answer? Perfect. So again, you can solve this multiple ways, but you can't solve it as the same way that you solve the first problem. So for the first problem, we didn't have this resistor. Therefore, and the input current in both of them are 0. Therefore, all the current will go through the feedback resistor. But in this case, the current is split between the 4 ohm and the 28 ohm. So you can't solve it the same way that you did the first problem. You can still use KVL, KCL to solve this. Another easier way to use to solve this is to utilize the source transform, which I've explained about in another class. I think it was the second week or so of the class. So if you have a current source connected in shunt or parallel with a voltage, a resistor, you can transform that to a voltage source, which is connected to the same resistor but in series. So it's going to be transformed to this. You're going to have the same resistor, but now Vs would be Is Rs. So I can use source transform to transform this to a voltage source. So it's going to be a 2.5 times 4, which is a 10 millivolts. Again, because that's ohm, I'm sorry, that's amp, so 10 volts. Yeah, change the numbers a little bit. If the input is in milliamps, this would be in millivolts. So 10 volts connected to RS, the same, which is 4 ohms, connected to the feedback resistor 28 ohms, connected to the op amp, giving it a feedback, and V out. So now it's much easier to solve. Can you tell me what type of op amplifier is this? It's a inverting amplifier because the input is connected to the inverting input. And for an inverting amplifier, V out is equal to negative R2 over R1 Vn. Therefore, V out is going to be equal to negative 28 over 4 times 10 volts, which gives us negative 70 volts. So in theory, this is possible, but in real life, op amps are usually limited to 30 volts max. So this is going to be actually go into saturation. So depending on the supply rail voltage, if it's like 16 volts, the maximum voltage that you can get for this is negative 16 volts. If it's 30 volts, it's negative 30. But in theory, you can have a 70 volts, negative 70 volts. Okay, did you write this down? Can I go to the next question? So for the next question, we have connected two amplifiers and Vn in this is 2 millivolts. We want to find V out. Did everyone solve it? Yes. Okay, so what we have here is a cascaded amplifier. Both of them are non-inverting amplifiers because the inputs are given to the non-inverting input. So the total gain, or in other words, let me write the final equation. V out for the system would be equal to 1 plus R2 or R1 for the first times 1 plus R2 over R1 for the second stage times the input voltage. So V out for this is going to be 1 plus 280 over 14, which is going to be 21, times 1 plus 12 over 4, which gives us 4, times 2 millivolts. So this would be 84 times 2, it's going to be 168 millivolts. Do you have the same results? Yes. Okay, perfect. And I think we have time for one more question. The final question, we're gonna have, did you all write this down or? Okay. So we have op amp with multiple inputs and we want to find the output. What is V out? I have to double check, but I think it's correct. Did you all solve it? Yes. What is the answer?
425 volt.
Okay, I think it's correct. I haven't solved it myself, but it seems right. So what type of amplifier is this? Yes, it's an inverting, and it's called a summing amplifier. And for a summing amplifier, V out for a summing amplifier is equal to negative RF over R1 V1, negative RF over R2 V2, negative RF over R2 R3 V3, negative RF over R4 V4. So V out would be equal to negative 150, because all of them in kilo ohms, I'm not gonna write the unit. So 150 over 15 times 10 millivolts minus negative minus 150 over 20 times 20 millivolts. 150 over 5 times 50 millivolts. And 150 over 30 times 100 millivolts. And what was the total? Negative 2.5 volts. 2.25 volts, yes. Okay. Did you all get the same answer? Perfect. Okay. A few things that I want to mention. The first thing is that this exam would be up to before the up amp limitation. So we're not going to have any of the upper cutoff frequency, lower cutoff frequency, gain product, gain bandwidth product, and so on of those. So it's going to be anything before like what we taught for the past 2 weeks. And I would highly recommend go through different circuits that we have, differentiator, integrator, competitor, learn them. You may have some questions from that as well. Your exam is going to be multiple choice exam, and all the equations that are required or are in the exam are going to be provided. So you don't, you're not allowed to bring any notes or anything. I will provide you with all the equations that you need. And that's it. Thank you so much, and I'll see you on Tuesday. The exam is going to be on the same time as. Yes. Yes, sure. First problem. Second one. Okay, thank you and have a great day.